there, my name's Rick Hurst. I'm going to be facilitating today's class. As you can see, we're at AWSome Day and we're going to be talking about tech essentials. We are due to have around 4, maybe even 4,500 people on this course. We shall see. We achieved that last time. Fingers crossed it should be an even bigger group this time. Again, we shall see. Before I jump into the agenda and tell you what we're going to talk about, I just want to get some initial housekeeping out of the way, how to get your questions answered, some basic stuff like that, and then we can jump into the content, okay? So what's the purpose of this webinar? The main objective that we have with Tech Essentials is just to get people to a certain point that they understand some of the common terms that are used when discussing AWS. We'll be discussing things like buckets, instances, VPCs, and if you've not heard of these phrases before, hopefully by the end of this class you have a better perspective on what these things are. So at least when you're talking to people about AWS, at least you can hold down a sensible conversation. That's the main objective. We're not going to go and do a real deep dive on anything in particular. However, we do have some pretty smart people helping out on this course, the SAs and co-trainers. What they're going to be doing is going to be assisting you with the deeper questions that you may have and chatting with you privately in the chat sections on getting your questions answered. But what I'm going to do is going to focus on the high level stuff, okay? Alright, so about me. I'm Rick and I am a technical trainer that works full-time at AWS in the training and certification team. I've probably been teaching for about 6-7 years. A lot of the time I was doing a lot of software stuff. I was doing a lot of front-end engineering training as well, like JavaScript, some of the CSS, HTML5 stuff. Moved into Node.js, Mongo and Redis and some back-end technologies. And probably over the last couple of years really shifted towards operations, and that's where I'm at right now. I'm teaching AWS to the enterprise. Prior to doing teaching, I was working as a software developer. So I come from the software dev background. I probably did about 10 years plus of that. Jack of all trades, master of none, poked around with many things in the web sphere. And, hopefully some of the questions that you have, if the essays can't answer it, maybe I can jump in and give you some pointers in the right direction as well. Okay? So let's have a look at the agenda and what we're going to talk about. We're going to start with Module 1, where we'll discuss AWS and general cloud computing concepts, why people are moving into the cloud, concepts such as hybrid, where people put a toe in the water and slowly move over to the cloud versus going all in. And some companies are even born in the cloud these days. The newer startups, they start there instead of on-prem. I will also discuss the foundational services, the core components of AWS, and then we will go a little deeper onto the platform services that stand on the shoulders of most of the foundational services. So my objective after Module 1 is to get you guys clued up on some of the core services we offer, why people are using cloud computing, that kind of stuff. And then based on when Ryan wants to do this, we'll do a quick break, about 15 minutes or so, and then we'll jump into Module 2, where we'll look at virtual private cloud, which is your network in the cloud, EC2, compute in the cloud, and also hopefully a little demo showing you how some of the console stuff works. One more break, and then finally Module 3, we'll look at RDS, Relational Database Service, DynamoDB, which is on NoSQL Store. We'll look at how to store things using Simple Storage Service, and of course, no course would be complete without discussing security and how we lock things down using identity and access management. Finally, maybe we'll do some closing remarks on where we see cloud computing going and maybe discuss subjects like Lambda very briefly. Okay, so that's the agenda for today. So I want to give you guys an introduction to Amazon Web Services and cloud computing in general. I don't want to give you guys a history lesson. I think if you're already here at AWSome Day, you know who Amazon are. But as you can see here on this slide, that in 2006 Amazon Web Services was created. And ultimately, this is the division that's growing the fastest. It's, I believe, it's the most profitable, and ultimately, it's driving some of the other stuff that we do at Amazon, such as Amazon Echo, and some of the home services that we have. So I'm going to deep dive more into AWS as we progress. Obviously, let's start with the high-level concepts. Generally, what is cloud computing? And the way I like to look at it is you're using someone else's computer. Yeah, cloud computing is going to be on demand, IT resources, via the internet, and you only pay for what you use. Very simple. If you spin up an instance, you're going to be familiar enough with what instances are soon enough. I'm going to talk about that in a bit. But if you spin up an instance, a piece of computing power for a couple of hours, guess what? You're only going to pay for a couple of hours. This is in stark contrast to your typical data center where you have to provision capacity. So that's a real core concept of cloud computing, pay-as-you-go pricing. So another way of looking at it is you don't need to build a power station if you just want to turn the kettle on. You should pay for services as and when you need them. And this is how we think of it. We think of them as measured services. And Amazon Web Services as a whole has many, many products, so you'll see that shortly. But ultimately what we do is we help businesses and devs to use web applications to build scalable, sophisticated, powerful applications. These are the main subject criteria which we're going to talk about in this course. Not all of them, obviously. I'm going to pick on a few of them to talk about, because otherwise we'll be here for about a week explaining every single service. I think there's nearly 90 services now. So this slide is talking about core infrastructure and the services, and what we like to do is we like to match like for like, and we do this because a lot of people that come to the cloud are familiar with traditional on-premises type systems, and they're familiar with all of these words like switches, routers, DAS, SAN, NAS. They know that world. So when they come over to working with the cloud, as close as humanly possible, we match them like for like. So, if you're familiar with firewalls, well, when you encounter our security groups, they're pretty much firewalls. Yeah, you get the idea. So your switches and routers, you'll be defining route tables in our VPCs. You'll be storing things across shared network devices. You do similar things in the world of storage in the cloud as well. So like for like, we match wherever possible, just to make it easy when we're discussing these individual things, because they go, oh, network ACL, oh, that's just like my ACL. Yeah, that's why we do it. 6 advantages and benefits of cloud computing. This is not necessarily specific to AWS. Certain things are that I'll touch on in a second, but mostly this revolves around all cloud computing in general. I think these are 6 very good reasons to think about when considering moving into the cloud. First one, of course, here is you're trading capital expense for variable expense. This is a big one. You don't have to build a data center if you just want to host an application or try and do some big data analysis. You can spin up instances of compute power as and when you need them, as we talked about, and then close it down when you're no longer needing it. This is great for experimenting. You could experiment with a project, you could try it, and if it works out, wonderful, just scale it up, no problem. And if it turns out to be a complete disaster, that's fine, you can scale it down as well. Just get rid of the thing. So, as far as agility and speed, great for experimenting. As far as saving money, well, it's awesome to be able to just pay as you go and not have to buy a data center or buy servers, on a smaller level. So those are very closely related. This one's an interesting one. The massive economies of scale. So Amazon Web Services have reduced their prices, I believe, almost 60 times since inception. Obviously, we're very customer-centric at Amazon. It's one of our founding principles. So wherever we can, we just try to save money, and we can pass that back onto the consumer and make happy customers, right? But it goes a little further than that, because we have great leverage with the partners that we work with. For example, we could go to Intel, or we have great working relationship with Intel, and we'd say, hey Intel, could you build us and work together with us on some really custom chip that would be fantastic for our customers? Or we can go to Juniper or some other company and say, could you build us a specific router? We've got these things that we would like to do. Could you help us do this? And we have such wonderful relationships with these people that we can then provide these services back onto the end user and leverage our so-called buying power, if you like, to pass that back onto the end user. So that's a very interesting one. I've talked about getting capacity. This is another one, going global in minutes. So think very small fry at this stage. You just want to launch a little website. You can do that in Virginia or wherever you're based, and then say, you know what, I'd like to do this in Singapore, or I'd like to do this in Australia. You can then launch a clone of your application and put it the other side of the planet, and you can do that in minutes. More about that later on. Very, very cool. Imagine trying to do that, buying a data center in Singapore, all the bureaucracy you'd have to go through. Even just organizing servers in another country can be very problematic. With AWS, press of a few buttons, job done. We have lots of features. It's pushing nearly 2,000 services and features there. I think, if you were to look in the AWS console, we'll show you that in a little bit. There's around 90 services, core services, but you can imagine within each service there are many, many component parts and facets of those services, and that gives you almost 2,000 features. Look at all these. On a course like this, where we only have a couple of hours together, we have to be a bit savvy with the subjects that we choose to focus on. So we're going to focus on the building blocks, the really important stuff. If you're interested in these other edge case things, of course, you can poke around in the docs, you can have a look in the console, and there's plenty of information out there. But I'm going to focus on the important stuff, alright? Incidentally, that's what the console looks like. If you've never been into the console, you would go in there and you would see all the services listed there, and you could click on them and start experimenting with them. Most of them would be on the free tier, which we'll also get onto in a little bit, so you can experiment and play around with these things for free to start with. You don't obviously have to go into the console, as we call it, to interact with AWS and all the services. You can quite happily use the SDKs, software development kits, or the command line interface, CLIs, and you can interact with AWS programmatically. You don't have to go in there pressing buttons. Either way, we make it very easy for you to access a broad range of services, and there's a lot of good docs surrounding those services as well. I want to talk a little more about infrastructure. I've said that you can go global in minutes. You can launch a website in Virginia, and next minute you can launch it in Australia. But how specifically is our infrastructure set up? This is actually our latest slide. We have 16 regions right now, and the numbers that you see inside those orange circles are the availability zones. I'm going to explain a little more about availability zones in the next slide, but the more or higher the number in those circles, the better for you guys. More about that in a moment. And the green circles are the regions that are coming very soon. Okay. As you can see, we're structured all over the planet. And it's not just this, actually. No, it's not on this slide, but there are loads of points of presence scattered all around there. I think there's almost 80 points of presence, and they are caching nodes. So that if you have content here, say you had a website here and you were hosting, this is somewhere in California, you were hosting a website and playing a video, you have someone way over here could actually not have to go all the way here for the video. They could get it from a point of presence somewhere around here, okay, and have it served locally to them. So they have lower latency, which means they get the video faster. Also relieves the load from your origin server over here as well. So we have some additional infrastructure which isn't displayed on this slide, called edge locations. So the phrases you'll hear about throughout this course will be region, availability zone, and edge locations. So let's talk about the AZs, or availability zone. As far as availability zones go, think of the building that you're in right now. It might have thousands of servers inside of it. So this is a building you're in right now, thousands of servers, right? And then there's a building maybe 100 yards away with thousands of servers in it, and then another building 100 yards away there. And this tight-knit cluster of buildings would be considered an availability zone, or an AZ. Call that AZ1. Now, I use the example of the building that you're in right now. You would not be allowed in one of these buildings. These are specifically designed to hold servers. They're not where Amazon employees are wandering in and out necessarily. They're specifically trained people. Like I can't walk into a data center, for example, even though I work for the training and cert team. So they're isolated from other availability zones. As you can imagine, we have multiple availability zones here, right? Each with buildings of thousands of servers in it. Once you have multiple availability zones, like 2 or more, you have what we consider a region. You saw that on the previous slide, right? The numbers inside those regions, those orange circles, with the number of AZs. You have very fast connection between them, but they're completely isolated. These are going to be on different electricity providers, different telcos. If this is on a fault line, for example, these ones won't be. That kind of isolation. Okay? And in some places we have up to 5 AZs. Talking of a region with 5 AZs, Virginia, 5 AZs. Tokyo, 3. The key takeaway from this is you must have at least 2 availability zones to have what we consider a region. The reason for this is because of a concept you're going to hear me talk about quite a lot: high availability. The idea that if, I think I used the example of a meteorite before hitting one availability zone, that wouldn't take out this one over here, okay, because they're far apart. And the advantage of having your infrastructure across servers scattered across availability zones means that when your traffic or your users try and access your site, they can either go here or they can either go here. I mean, in some cases you might want to say, well, let's have a third really or ultra high availability, by having 3 or more copies of your content in different availability zones. We suggest that you only need to have 2 availability zones for high availability. Okay. Some companies like to have their content scattered across multiple regions. Yeah. I personally think in a lot of cases that's overkill. I think as long as you have your content in multiple availability zones scattered across, say, the whole of California, that's, in my eyes, good high availability. And I think once you start going to 3, as you see on this slide, again, a little bit overkill, and also it's a little more price, isn't it? Because you've got 3 times the content, and I think the bang for buck starts to decrease once you go above 2. That's just my take. So let's talk a little more about that edge location concept. It says here there are 70 edge locations. Okay, they keep growing, so there's more and more of them coming. And it's not necessarily just where you cache content, and that would be where we use a service called CloudFront. Using the video example from before, where you host a video in Virginia and you let someone over in India view that from a point of presence nearer them in India. Okay, that's what CloudFront's all about. But it's not just CloudFront. There are some other services surrounding these edge locations, one of which is DNS resolution, Route 53, Web Application Firewall, and Shield. I'm going to talk more about these a little later on, so I'll save that for later. So I want to wrap up this particular section with a quick knowledge check. Don't worry, we're not going to be asking you to type in answers or do any polls yet. Maybe Ryan might have that for you later on, we'll see. But for now, I'll just read this off to you. So what is the AWS term for physically distinct groups of data centers within a region? I'm hoping you know the answer to that, and that is availability zone. You all got that right? Yeah? True or false? There are more regions than edge locations. What do you think? That's going to be false, isn't it? Many more edge locations than there are regions. True or false to this one then? AWS owns and maintains the infrastructure required for application services. You provision them and use them as and when you need them. It's pretty obvious that that's true, isn't it? And finally, if you get this right, we can move on to the next section. How do availability zones in the same region differ? Give you a chance to think about that for a second. It's to do with isolation. Each AZ is isolated, but the availability zones in a region are connected through low latency links, so it's very fast connections, but they're isolated. That's the important thing. Okay? Wonderful. Alright, next module. So, platform services. Remember when I said I wasn't going to cover every single service? That's not going to be possible. What I am going to talk about is some of the core services that make up AWS. This is broken into 2 main concepts. we have foundational services, and then we have platform services. I'm going to explain foundational services first. And you're probably thinking, well, why does he have platform services on the slide right now? And that's because what you're looking at right now in terms of platform services, I'm going to explain them all in a minute, but they stand on the shoulders of the foundational services. Okay, so be aware that all of the things that people use day to day when they're working with AWS, the most common tasks, things like DevOps, where you're deploying code, things like you're logging in with Facebook or Google if you're building a web app, doing full text search with Elasticsearch or transcoding videos. Common things that people do are available as platform services, but they all stand on the shoulders of the foundational services. So I'm going to talk about that first, and then I'm going to come all the way back to this. I'm going to explain what these platform services do. By then you'll have a higher understanding of how they're actually working under the hood. So let's talk about the foundational stuff, okay? And here we have it, the foundational services. We break this down into 5 major categories: compute, network, storage, security, identity, and applications. I'm going to start with compute, and then we're going to work our way right across the screen. Now, even if I was to spend, a couple of minutes on each one, this is still going to take a long time to get through. So I am going to try, as much as I can do, to explain each individual component part in a very short space of time, because we just have a lot to get through. Okay, so I'm going to start on the top left, and we're going to work all the way down, and hopefully by the end of this slide, you got a rough idea what all these things are and what these symbols mean. Okay, so let's start with compute. EC2, this is virtualized environment. Okay, what does that mean in English? It means if you want to spin up a Linux machine or a Windows machine in the cloud and just pay for the time that you're running that computer in the cloud, then that's all you need to do. You just pay as you go for computing power in the cloud. And we call this compute in the cloud instances. That's a phrase you'll hear a lot of. And this is Elastic Compute Service, EC2, and you can have various flavors of instance in the cloud. Very powerful ones, tiny weeny ones that aren't so powerful, ones with loads of memory, ones with loads of CPU, ones with loads of storage. You've got loads and loads of different options, and we'll get into the details of EC2 because that's one of the chosen ones that I'm going to focus on in the course. I'm going to spend a bit of time on EC2. So at this stage, all you need to know is it's a virtualized environment. It could be Windows or Linux, and you've got different powered levels of computing power that you can use. Alright, so that's EC2. EC2 registry and EC2 container service. These two relate to something called Docker. Okay. When I mentioned before that you have instances and you can put any software you like on this, well, with Docker, it allows you to get a little more savvy with the space on the computer, because what you can do, and I'm going to change colors for these different boxes, is you can have little containers in here, each running different things. So normally if you just had a normal machine like that green box and you decided to run Node.js in that, you would have to configure that for Node.js. And if you wanted to configure it for Python, you'd have to install Python. Yeah? Well, with this, you're allowed to have maybe a Node.js application here, a PHP application here, and a Python application in here, all running completely isolated from each other on one machine. This makes the most space of the actual machine. And think of these as shipping containers. You know, where if you're moving house and you had all your furniture and you put it in a shipping container, and then you can move that shipping container and drop it somewhere else. This is the beauty of Docker. You can develop locally in these boxes and then just literally ship them off into production, and they can be running in the cloud for you on these machines. So the concept of Docker is pretty straightforward. It's a bit like that Inception film. You have a virtualized environment inside a virtualized environment. Okay. Docker itself is straightforward. The challenge is when you start coordinating which machines to put the Docker containers on and start scheduling them and that kind of stuff. It gets a little more gnarly. So we have a service called ECS Container Service that manages that for you. And obviously you're going to need to put this information in a repository, and we have a repository registry service for that. So those two are very closely related. Okay, so that's Docker. Lightsail. This is a standalone service that allows you to get up and running in the cloud very, very quickly. If you just want to build a basic website, maybe you had an idea for a WordPress website for a local blog, that's the kind of thing Lightsail allows you to do. You can pick the size of compute power you want. You get a certain amount of allocated memory, certain allocated amount of CPU, certain storage, certain bandwidth, and then you buy a package and you just get up and running really fast. I would recommend, if you're interested in that kind of thing and just getting a website up and running real fast, definitely have a look at Lightsail. It just gets rid of all the grunt work involved with setting up basic web applications. And that's how it's positioned. It's for very high level users, people that don't understand so much about VPCs and auto scaling, but just want a website to work. That's what Lightsail's for. VPC, this stands for Virtual Private Cloud. This is your network or your data center in the cloud. Just like you would have an on-premises data center where you can control your IP addresses, you're controlling your firewall rules and your networking and how your traffic is moving in and out of your network. That's what VPC is all about. We will spend a bit of time on VPC, just like EC2, because that's one of the core concepts. VPC is something I'm going to spend a bit of time on. So I'm actually going to defer explaining VPC in any detail to further on in the course, because it's a quite involved module. There's a lot going on in there. It's very powerful. So from a high level, it's a network in the cloud that you can completely control. Batch is related to obviously batch processing, where you have a lot of workers that will be working through a queue of tasks. The challenge when you're working with batch processing is you're going to have to figure out the right type of machines for the right type of job. And scheduling that and organizing the types of machines that you need to handle batch processing can be a bit complicated. So we have a service called AWS Batch that will take care of that for you. It will optimize the machines to run your batch processes on, it will schedule them, and it will organize your batch processing for you, so you just focus on analyzing the results. So it's related to batch processing, hence the name. Elastic Beanstalk, it's very similar to Lightsail in a lot of respects. It gets you up and running really quickly in terms of building web applications and worker applications. I would say it's a little more involved than, say, Lightsail, where you just buy a package and you're up and running. Beanstalk, you have to do a little bit of configuration, but it does take a lot of the grunt work away from building applications. You might just want to have again, using the WordPress example, you build a WordPress application. You don't necessarily want to get involved in organizing auto scaling, load balancing, setting up RDS, which we'll also get onto later. You just want it, again, to work. That concept, like with Lightsail, you just want it to work, but you want a little more fine-grained control over what you can and can't do and how things are operating within your system. So I think it's a more advanced version of Lightsail that lets you pretty much go under the hood and start poking around. But again, it is a highly opinionated system that will build an infrastructure for you and avoid you having to get involved in the grunt work in terms of setting up your operations and setting up your infrastructure. Lambda, this is a game changer. It really is. It's very, very cool. Remember before I said you could have an EC2 instance that would run and you only pay for the time that it's running, okay? Well, if you have a website and you say you had a rubbish website and you're only getting one hit a month, right? With an EC2 instance, you're paying for that machine 24 hours a day, 7 days a week, just to maintain access for your users. And if it's just one user, it's very wasteful because most of the time it's not being used. How much better would it be to have your user come into your application and Lambda, AWS Lambda, will just handle that and then turn itself off when it's done? And maybe that's 100 or 200 milliseconds of compute time, and you only pay for the time it's running versus 24 hours a day, 7 days a week for an EC2 instance, right? Much more cost effective. No need to worry about auto scaling and load balancing, which we'll get onto in a little bit. With Lambda, you're only paying for the compute time that your functions are running. Lambda is one of those other core areas I'm going to focus on later on, so we will get a chance to look at that a little deeper because it's a very interesting subject. Finally, in the compute section, load balancing. I think the name pretty much tells you what that does, right? So imagine these blocks here are machines. How about this? That could be a load balancer, and what that would do is when traffic comes into this device or set of devices, nodes, it routes traffic to healthy machines. Okay, so if one of these machines happens to be unhealthy, guess what? It stops sending traffic to it and sends it to the healthy machines. Later on, maybe this resurrects itself and starts becoming healthy again, and in that case, great, start sending traffic to it again. Balancing the load across a fleet of machines, only sending traffic to healthy instances. I think it's a common sense concept. It decouples your users from your application, which means if this machine goes down, the user is not interrupted. It's a very cool concept. I'm going to be discussing that a little more detail when I talk about EC2 and load balancing and auto scaling together later on. Okay? So let's look at the network. There are 5 component parts here: CloudFront, Route 53, Virtual Private Cloud, Direct Connect, and Load Balancing. Well, here's the good news already. We've talked about VPC briefly. We're going to discover more about VPC later on when we get into the weeds on that. We've talked about load balancing, so I'm going to scrub that one out viciously. Here we go. I've touched on CloudFront already, actually. This was where we have our caching nodes. You know, the example of storing the video in Virginia and somebody over in India being able to watch that locally to them because they have lower latency and relieves the load from your origin server. That's really what this is about. You don't store infrastructure on CloudFront edge nodes. What you're doing is you're storing your infrastructure in your region, and then you're setting up a CloudFront distribution to go and fetch that from the origin and display it to the user with lower latency. So it's not that you put infrastructure in CloudFront, it's the fact that it gets cached at these edge nodes. That's really what it is. Now, of course, it does more than that, and there's loads of things you can do with it. But from a high level, they're just caching nodes. Incidentally, at these edge locations, we also have Route 53. And Route 53 is domain name resolution. So if you maybe have a domain name, example.com, and you want to route or resolve the mail servers, the MX records, to one place, and you want to resolve the A records and C names to a different place to host a website or web application, that's what it's for. You have fine-grained control over DNS settings on your domain name. You can either bring a domain name in, or you can even buy one from Amazon as well. That's Route 53. Let's talk about Direct Connect quickly. So with Direct Connect, it is simply a direct connection between your on-premises system. This is your building on-prem, and this is the AWS cloud with a VPC. What you will do, instead of going across a public internet, this is the public internet, you can create a direct connection. Let's change ink. A direct connection to your VPC from here all the way into here. This is a little more complex than that. There's usually a co-locator provider and other things, but you get the idea. Is that what you're doing is you're bypassing the public internet, which is a little bit flaky, right? You want to go and have a direct connection to the cloud to give you a reliable bandwidth, reliable connection, and all that good stuff. It's very useful if you've got a lot of data on-prem and you're trying to get all that into the cloud, or vice versa, and you're dealing with lots of data transfer and you need that reliability. Then Direct Connect's probably for you in that case. Okay, so that's networking. Let's move on to storage. Again, we have 5 component parts of storage: EFS, Glacier, S3, Snowball, Storage Gateway. We are going to spend a bit of time on this one. We kind of touch on this as well. But let's start with EFS. EFS, Elastic File System. If you have multiple instances that need to have a shared file system, so instance 1, 2, and 3, and you want to share access, then you can do this. You can mount EFS to all these individual machines, and then you can share a common file system, which is very nice. Incidentally, the reason why we created EFS is because people were trying to do that with S3, I'll explain S3 in a second. And it's not really, S3 isn't a real file system. You'll see that when I get into the weeds on S3. But this is a proper file system, and it's designed to have multiple mount points with different EC2 instances. Okay. Glacier. This relates closely to S3 in a lot of respects. But when you have items that you store, such as images, videos, database backups, logs, lots of varied data, you need a centralized place to put that. And so we have a regional service called S3 where you can put this object store. It is ultimately a key value file store. It's not really a proper file system. You're simply creating a key and a value, and that value can be anything, blob of data, image, video, doesn't really matter, and it can store an unlimited amount of data in there. Glacier is where you do that, but you store it for the long term. So I like to think of Glacier as S3 on ice. In S3 you're going to store your objects for immediate access, but with Glacier you don't have immediate access to it. You have to go and recover it, and it takes a couple of hours to get that information back. But the advantage of throwing something in Glacier rather than S3 is it's dirt cheap. It's much cheaper to store your objects in Glacier on ice than it is to store it and have it immediately available in S3. Now S3 is one of the other services I'm going to spend a lot of time on. There's a lot going on with S3, so I'm going to reserve discussing the concepts of S3 until a little bit later on. So, Storage Gateway and Snowball, these are mechanisms on how to get information that you maybe have on premises into the cloud. If you have a lot of data on-prem, yeah, you can use Direct Connect and have a better internet connection and ultimately send traffic up that way. And Storage Gateway works really well with this, and it allows you to decide how much information you want to store locally versus how much you want cached locally and store majority in the cloud. You have these various flavors of Storage Gateway depending on your use case, but ultimately what it's doing is bringing stuff from on-prem into the cloud. Now, what happens when you have tons and tons and tons of data? The best way to get data into the cloud is not with Storage Gateway and it's not with Direct Connect. It's getting all your data into a box and putting it on the back of a truck for ultimate bandwidth, right? And that's what Snowball is. It's a device that you load your data onto and then you ship it to AWS region, and then we unload it into your cloud. So they are just mechanisms to get your stuff into the cloud. Security and identity. Obviously we take security very seriously at AWS, and as such we have a mechanism for handling which resources in your infrastructure have access to other resources in your infrastructure, and ultimately which users in your organization have access to said resources. All of that stuff is handled with what we call Identity and Access Management, IAM. You're going to hear a lot about that. I'm actually going to spend quite a bit of time on IAM later on, so I'm going to reserve discussing that for later. Let's just touch on some of these other things here. When you're working with security, you find yourself sometimes not following best practice accidentally, and as such we have something called Amazon Inspector that's going to look at the security that you've set up for your infrastructure and give you a prod in the right direction. It's not going to change anything, it's just going to say, hey, you probably don't want to leave all the ports open on that particular machine over there. That kind of stuff is just going to nudge you in the right direction in terms of best practices. As far as Artifact goes, this is if you're dealing with compliance and you're looking to get documentation for HIPAA compliance and PCI compliance, and if you're in that world, I would recommend you look at Artifact to get documentation related to your compliance issues that you have, but it's related to compliance. Cert Manager, this is very cool. This is actually one of my favorites, because as you know, your Joe Blogs web developer that gets these certs that you have on your website to get that nice little green padlock on the website, they used to cost a decent amount of money, like $70 a time, for a wildcard cert. You can actually get that free with Amazon now, which I thought was really amazing. To be able to go in and get your green padlock for example.com and have wildcard certificates so you can apply to various component parts of your infrastructure like CloudFront. Very, very cool stuff, completely free. one of my favorites. Cloud HSM, this is to do with tamper-resistant modules that we have in the cloud. They're not cheap, okay? But it just means that if you have very, very sensitive material and you're very concerned about compliance, we have mechanisms whereby you can ultimately have a machine in the cloud dedicated to your use that's very, very particular with how it handles data. If you try and tamper with the device, it can delete the keys, that kind of stuff. I'm not going to go into the details on that because we don't have time. But if you're involved with things like HIPAA compliance or a government organization really concerned about security, then Cloud HSM might be something you want to look into. Forewarning, it's not the cheapest product in the world. Directory service is nothing more than Microsoft Active Directory, or a dumbed down version that we have called Simple AD, more of a lightweight version of the Microsoft Active Directory. So if you have an organization that already has authentication in place using AD, then you can bring that into the cloud, and we have various mechanisms for connecting your existing system into our system. Many companies already have that in place, and they don't want to have to rebuild an entire authentication system, so we can use directory service for it. I'm going to come back to IAM. KMS, Key Management Service. When you're encrypting content in the cloud and maybe storing it, say in S3 for example, you can use our encryption system called KMS, or you can use your own keys. You might have your own encryption system managing your own keys. If you're in that game, then you can bring your keys into our system and use your encryption system and the keys you manage with the objects in the cloud. So you've got a choice. You can either use your keys or you can use our keys. Either way, KMS and Key Management System allows you to orchestrate all of that, and it helps you meet compliance. Organizations. Well, if you have a larger organization and you have multiple AWS accounts, you might have multiple VPCs inside those accounts, but ultimately if you're managing large groups, you probably want to take advantage of things like tiered pricing. You want to take advantage of coordinating the groups together, and as such we have a system called Organizations that allows you to coordinate and manage that a little more effectively. And obviously it's very sensitive to security, and there's a lot of things that you can apply in terms of organizations for security and identity management. And finally, Shield and WAF, these are kind of closely related. Web Application Firewall would sit on CloudFront, and what that allows you to do is when requests come into your edge location, you can filter that out. You could perhaps whitelist certain IP addresses. You could look for things like SQL injection attacks and nefarious access, and you can block that before it even gets to your region. Great for things like distributed denial of service attacks. I'm not going to go into the details of different mechanisms for intrusion like DDoS and these kind of things, but if you're concerned about that level of security and you're concerned about attacks at your system in the cloud, Web Application Firewall will help to mitigate that. And more importantly, if you're enabling Shield, that is going to give you this extra level of protection, an extra level of comfort related to security at the perimeter. And I believe there are options related to Shield, and again you're going to have to check the docs, but if you do get a distributed denial of service attack, there is some kind of compensation involved. But in other words, as long as you're doing the right things as far as we're saying the best practices, Shield will protect you not just from a technical standpoint, but from a financial standpoint as well. And again, I'm going to refer you to the docs on that. And on the far right, we have applications, WorkDocs, WorkMail, AppStream, Workspaces. I'm currently using Workspaces. I don't know if I can demo that from here. Let's try. See this? This is a Mac, right? But yeah, I'm running PowerPoint, and that is because I'm on a Windows machine. I wonder if I can just come out of this real quick to show you. Here we go, look. See, I'm on a Windows machine, right? But really, I'm on a Mac. Funky, huh? So if we can get back to what I was doing. I lost my slide. Let's try that again. Always dangerous going off track. There we go. Whoops. Anyway, That's Workspaces. It's very cool. It's great for things like disaster recovery. I mean, if, for example, if I was presenting, because I often go and travel to present, if something went wrong with my machine, I could borrow somebody else's machine, log into my Workspaces, and carry on presenting. Okay, so none of the PowerPoint slides that you're looking at right now are actually on my machine. They're actually stored in Workspaces in the cloud, which is kind of cool, huh? As far as Work Docs and Work Mail, well, Amazon have their flavor of, like Google have theirs. They have Gmail, they have, like G Suite. You've got Word documents of sorts. You've got Excel spreadsheets of sorts. They've got their own type. We have our type, and they're Amazon Work Docs. So if you want to do spreadsheets, PowerPoints, equivalents, we have ours. Okay, and AppStream is a bit like Workspaces in a lot of respects. That allows you to set up multiple users to have these remote desktops and push software into them. So, for example, I'm running PowerPoint right now, but if I said I would like to have Visual Studio, even though Visual Studio isn't installed on my Workspaces, we could use AppStream, or as we call AppStream 2, and I could send Visual Studio into my virtualized environment. And then I could operate Visual Studio, and I wouldn't have to download it, it would all just automatically be there. And as an organization, you can manage your users and which software that they have. It's very, very cool. That's called AppStream 2. That's it. Foundational services, over. Alright, so I'm going to jump over to platform services now as the next module. See you in a minute. So, AWS platform services. We're not going to do what we did last time and spend quite a bit of time on each one. Because there's so many here, I'm going to try and be a bit smart with the way we do this. Many of these are actually duplicated. I mean, these are the latest slides, but we see Redshift on here twice, we see API Gateway on here twice. As far as this one here, DynamoDB and RDS, I'm actually going to cover those separately later on, so we're going to go into depth on those two. I'm also going to go into depth on, even though it's on here twice, I'm actually going to go into that one as well later on. The rest, I'm going to cover those, but I'm going to cover them very, very high level and very quickly. We also covered that one on a previous slide. So this is what we're going to work from. I've modified the slide, this one, okay, and I'm going to go through these, okay? Start with Elasticache. If you have a database, okay, so that's a database, and then your users are accessing your database. This is a user, okay. If that is a very expensive query, wouldn't it make sense to store the answer in another database or in memory? So the next time a user comes to ask that same question to that database, instead of going through the motions of that long expensive query, it can just get it from the cache. And that is an in-memory database storing results from your origin database, and that is Elasticache. We have a few flavors of Elasticache. We have Memcached and we have Redis. Ultimately, they're key value stores, so they're very simple to use. And it's not only used for caching at this level. Some applications will use this to store session information for maybe shopping cart, that kind of thing. It's very useful for very quick lookups of key value stores. That's all it is. It's a managed service that sits on top of EC2 ultimately and produces these cache nodes for you. Okay, so that's Elasticache. Redshift is just about handling massive volumes of business queries. So if you had a traditional database and you start doing very, very expensive, convoluted, complex queries on that data, it starts to fall down a little bit. When you have a columnar warehouse system like Amazon Redshift, it's perfect for that stuff. It's designed to handle massive amounts of data, petabyte scale. We're talking huge databases here. And that can be queried and use very expensive, elaborate queries on that data, and it can run it in parallel, and it can do it very, very well and very, very quickly, and it's a fantastic tool for what we call BI or business intelligence. Ultimately, the results you'd get from something like Redshift when you're doing these complex queries could be demonstrated in a visual tool such as something like QuickSight, which is nothing more than a visual tool, to display, charts and pie charts, graphs, this kind of stuff, explaining your data and visualizing your data. Those two work very well hand in hand. We actually do full 3-day courses on this, so obviously it's a bit more involved, but it's a high volume, massive database for very expensive, intelligent queries. That's all that is, okay? Also got to cover QuickSight there, so knock that off the list as well. Awesome. So analytics, we've just briefly talked about that one. Elasticsearch, we'll start here. If you have a lot of data to analyze and you're trying to do things like full text search, traditional databases don't do that so well. Some do okay, but Elasticsearch is really good at this stuff. If you've got perhaps web logs and you're trying to find out which browser they were using to access your website, and you wanted to search on keywords like Chrome and Firefox, that kind of stuff, and get through reams and reams of text, Elasticsearch is really good for that. So we have a managed service which will allow you to build an Elasticsearch cluster. Ultimately, what people tend to do with Elasticsearch is to add Logstash to it, so that you have a way to ingest all of these logs almost in real time. And then it's called an elk stack, where you have Kibana as well. And Kibana could be run on EC2 instance, and Kibana is a visualization tool very similar to QuickSight. So that's an elk stack, and we have the managed service called Amazon ES, which is Elasticsearch. It's very closely related to this one actually, because on Cloud Search, this is something that you add to an existing database infrastructure to allow you to do the full text searching that you would get with, say, Elasticsearch, without having to have a full Elasticsearch cluster. It's a managed service that essentially augments and supercharges your existing database to allow you to do really clever text searches. So when you start typing and searching for something, it will say, "Did you mean this?" If you want to build apps of that complexity, Cloud Search would be a really good way to augment your existing system to give you an Elasticsearch style query. So that's those ones. Two more on here. That was a bit messy. Let's clean this up. Kinesis and Athena. Let's talk about Athena first, okay? So Athena is a very quick, easy way to get up and running with analytics. The best use that I've seen for Athena is things like weblogs. Right? So if you have a typical S3 static website and you're collecting weblogs, all you would need to do is point that bucket that you're collecting your logs into to Athena. And what it will do is it will analyze that data and allow you to do SQL queries on that data. Without having to build a big EMR cluster, a MapReduce type cluster, which is what we obviously have that as a managed service as well, called Managed Hadoop. For those of you who are involved in big data, you know what Hadoop is. We have a managed service for that called Amazon EMR. But instead of building a big EMR cluster, you can just point a bucket to Athena, or it doesn't need to be a bucket, it can be something else, because some of the other services that pipe out data can be analyzed in Athena, and this allows you to do very quick, fast and easy SQL type queries on your data without building clusters. So this is a lightweight version of this, and in most cases it does a really good job. When I do a lot of the EMR training, some of the labs that we do within EMR could easily be done with Athena in a fraction of the time, because they're contrived lab type examples. So when you're dealing with big data, ask yourself, do you really need to have a big full-on cluster? Because very often you can get away with just using Athena. Okay. Finally, Kinesis. This is a way to ingest a massive amount of data from various sources and make sense of that data in real time. So when you had EMR, this is looking at cold data, maybe data you've stored for months. Okay. Kinesis is data that's happening right now. So a Kinesis stream, you can throw all sorts of data into that in all sorts of different varieties. You could have web logs, clickstream logs, custom metrics thrown in there, and what you then have is a series of applications which can analyze these pieces of data at the same time as they move through the Kinesis stream in real time. So what I think of Kinesis is real-time big data. Obviously we do full-on courses on Kinesis, so we can spend days talking about it, but from a high level, it's just a stream that can ingest tons and tons of data extremely quickly, and you can analyze that data very, very quickly, and you can analyze the same piece of data from various sources. Okay, that's all prepared to go into Kinesis on at this level, I think. Let's move on to app services. Awesome. Hope you all enjoyed your break. I was hoping to try and get through this before the break, but we just had a little too many things that we needed to get covered. Fear not, we only have about 5 or 6 more minutes on this just to wrap up, and then we're going to start going some deep dive. Okay? Alright, so let's get through the rest of this. So we have 2 here that are very closely related, simple workflow and step functions. I like to think of step functions as simple workflow service 2.0 because it's just generally better at doing all the things that happen in here. What you're doing is, instead of having EC2 instances coordinate some of the tasks in SWF, which I'll explain in a second, you're using Lambda functions, you're doing better try-catch error handling, you're running things in parallel. Okay, so in contrast to SWF, which I'll explain in a second, this is just the same stuff as this, but just much better. Okay, so that gets me out of explaining step functions. It's Lambda functions doing what SWF does, but just much better at it. Okay, and it's the newer, cooler kid on the block. So let's just briefly talk about SWF first. When you have long-running processes, computer processes tend to time out. For example, if you place an order on a website, you might need to validate a credit card. Once you validate the credit card, you might need to then place the order, as in someone has to pull something off a shelf and put it on the back of a truck, and that has to go on a road, and so on and so on. Once you start getting involved in these human processes, you need to have a way to track that in case maybe the truck breaks down. You don't need to then go and revalidate the credit card, right? Because you've got a workflow history of what's actually occurred. Managing that kind of thing needs a process, and we have a process called simple workflow, and it works very well, but it's very synchronous, meaning that it takes one thing after the next after the next. If you want to run many things in parallel and coordinate them in a very intelligent way, a more cost-effective way, you really want to be using step functions. So those 2 are closely related, SWF and AWS step functions. Let's talk about Elastic Transcoder. All it does is transcode videos and images. Very, very simple. You could, of course, do this yourself. You could launch an EC2 instance, install Fmpeg, and start transcoding videos into different formats to display on different devices. You can do that manually. But we have a platform service that takes care of that for you, because devices are changing all the time, new formats are coming out all the time, and new standards are taking place. It's very hard to keep up with that and handle videos and images for different formats and different devices. And as such, we have a managed service for it, just to alleviate some of the grunt work involved in transcoding images and videos. That's about it, okay? So the management tools, we have a few things here. So this one here, CloudFormation, is one I'd recommend you look into. It's too deep for this course, but it's about scripting your infrastructure. So all the stuff that you may have done in the console, pressing buttons and using the SDKs and CLIs, can be done in an automated fashion using a text file. And I would highly recommend, if you're serious about learning AWS products, get involved in CloudFormation. But again, it's too deep for this course. I don't really want to go into that one. And the same goes for OpsWorks. This is just done at a platform level, allowing you to configure all your servers. You're installing Ruby on Rails, maybe you're installing PHP. There's all these things you would need to do. We have a managed platform for handling and orchestrating that. So when you're working with a lot of these services that I've talked about so far, you're going to be following some best practices. And so as such, we can use Trusted Advisor to look and see if we're following said best practices. If you leave a server open to the world in terms of security groups, Trusted Advisor is going to give you a nudge in the right direction, a bit like Inspector, but just more of a high-level best practice tool rather than a security-based tool. And as far as config and CloudTrail and the managed services go, this is just more to do with auditing and to determine who did what when, and coordinating whether a person was allowed to do something and what they did in terms of what they changed to maybe a security group or an RDS database, and how that impacted the other services. So when you're involved in auditing and finding out who did what when, things like CloudTrail and config allow you to organize that in a very compliant way. Managed services, again, is kind of related to the ops work. Organizing fleets of servers, managing commands on those servers can get a little complex. We have managed services for that. The only one I've missed out here is CloudWatch. CloudWatch very simply allows you to collect metrics from various entities that you have within AWS. Every entity is going to report its own flavor of metrics. EC2s report their thing, load balancers report their thing, and as such you can collect all of that data, set alarms based on thresholds, and create event-driven programs in your system. Maybe if you have your CPU is at 90% on your EC2 instance, maybe you need more EC2 instances. CloudWatch is the basis for be able to analyze what's happening and react to it. Okay, they're your management tools. So the dev tools, this is an easy one for me to cover because we're not going to go into it. We have 3-day courses on DevOps, the concept of DevOps. When you start pushing code up, you push that into some sort of pipeline process that does a build, and it builds your system and then pushes that into production and this kind of stuff. Code commit is a bit like GitHub of sorts. Code deploy puts your code on certain machines. Pipeline is the whole process for managing it all. And X-ray analyzes your apps to find out what's actually going on inside of that, which queries are taking longer and that kind of thing. So all of those things are in a subject called DevOps, and I am purposefully moving past it for time purposes. We do 3-day courses on it, okay? As far as mobile services go, when you start building mobile applications, we'd recommend using Mobile Hub. This is going to give you a load of working code to get up and running real fast. It coordinates many aspects that are involved with mobile development, such as analytics, finding out who's doing what inside your application, pinpoint in terms of sending emails out and actually getting your messages to your users, and even testing your application on real devices. Even logging in with Facebook, Google, and this kind of authentication system and managing data across devices. All of that type of thing needs to be coordinated when you're developing mobile apps, and we have Mobile Hub that incorporates all of these things. That's all that is. Okay. And finally, Internet of Things. So you've seen these devices, these home automation devices, pretty much everywhere now, like little dash buttons. When you have a device that is collecting lots of data and sending that up to the cloud, you need something like AWS IoT as a managed service to coordinate that and handle those billions of messages potentially, and coordinate that across multiple devices all over the world. Doing that kind of stuff is not straightforward to do yourself, so we have a managed service to help you coordinate that. We've recently implemented Greengrass, which is just Greengrass over here, and what that does is that allows you to coordinate Lambda functions at the device level. In other words, you can almost filter out some information that you don't want to send up to the cloud, that kind of stuff, and adding a little bit of extra intelligence at the device level. And that's relatively new as well. So as far as Internet of Things, we have you covered for that as well. Alright, that's it for platform services. Let's move on to some more interesting deep dive stuff. Here we go.